We've got an absolutely mind-blowing topic that's going to keep you glued to your screen. Imagine a spacecraft launched over 40 years ago that's still out there, beyond the edges of our solar system, sending back messages. Yes, we're talking about the legendary Voyager 1. But here's the million-dollar question: how far can Voyager 1 go before we finally lose contact? Back in 1977, NASA launched the Voyager 1 space probe with a mission to study the outer reaches of our solar system. Now, 41 years later, Voyager 1 holds the title of the longest operating spacecraft in spaceflight history. It's currently hurtling through space at an incredible 61,000 kilometers per hour and is about 19 billion kilometers away from Earth. Despite this unimaginable distance, we're still able to communicate with it. But for how long? To understand this, we need to explore how Voyager 1 sends and receives data from such a vast distance. It all starts with a powerful 20 kilowatt signal transmitted from Earth to Voyager 1 using radio waves. This signal travels for almost 20 hours before reaching the probe's sensitive antenna. For context, it takes the rovers on Mars an average of just 15 minutes to send messages back to Earth. Once the signal reaches Voyager, it sends data back to Earth using a much weaker 20-watt signal. By the time this signal makes it back to Earth, it's barely detectable. The secret to maintaining communication isn't about the strength of the signal but the sensitivity of the receiver. NASA's Deep Space Network, which has 3 antenna complexes around the globe, plays a crucial role here. Each complex boasts a massive 70-meter antenna along with multiple 34-meter antennas. These can be combined to pick up signals that are thousands of times weaker than your standard FM radio signal. The Deep Space Network spends several hours each day listening for Voyager 1's faint signals, and so far, it's still talking back to us. Thanks to decades of technological advancements, there's no real limit on how far we can communicate with objects in space. Our current technology allows us to reliably communicate with objects that are many light years away, as long as our receivers are sensitive and accurate enough to pick up the extremely weak signals. However, as Voyager 1 travels farther and farther away from Earth, it takes longer for signals to be sent and received. The signal strength diminishes, and data rates slow down, making communication more challenging. Voyager 1 is nuclear-powered, and its electrical power weakens each day. Back in 1990, to conserve power, engineers turned off its camera after capturing the famous pale blue dot image, showing Earth as a tiny blue pixel against the vast darkness of space. Today, only 4 out of the 11 scientific instruments on Voyager 1 are still active, collecting crucial data on magnetic fields, solar winds, and cosmic rays outside our solar system. In about 8 years, Voyager 1 will completely run out of power and will no longer be able to operate its instruments. Until then, scientists will continue to communicate with the probe and receive the valuable information it gathers. Eventually, it will send its last piece of data and drift silently into the void, never to be heard from again. As the end draws near for Voyager 1, we should take a moment to appreciate the incredible journey it has been on and the wealth of scientific knowledge it has provided. This mission has inspired generations of scientists and space enthusiasts, and its legacy will continue to influence future space exploration. Thank you to the Primal Space patrons who help support and research our videos. If you'd like to contribute to Primal Space, please visit patreon.com/primalspace, where we're doing a giveaway of a Saturn V LEGO set once we reach 50 patrons. Make sure you're subscribed so you can join the discussion as we continue to explore and learn more about the wonders of space. Thanks for watching, and I'll see you in the next video. Voyager 1's mission to explore the outer planets has given us invaluable data about Jupiter and Saturn, including their atmospheres, moons, and magnetic fields. One of the most significant discoveries was the detection of active volcanoes on Io, one of Jupiter's moons, the first time active volcanoes had been observed on another celestial body. Voyager 1 also sent back detailed images of Saturn's rings and discovered new moons around the planet. The spacecraft's close encounter with Titan, Saturn's largest moon, revealed a thick atmosphere primarily composed of nitrogen with traces of methane, prompting further exploration by missions like Cassini-Huygens. After its planetary tour, Voyager 1 embarked on its interstellar mission phase. In 1990, it took the iconic pale blue dot image, capturing Earth as a tiny speck in the vast expanse of space, emphasizing the fragility and isolation of our planet. One of the most impressive aspects of the Voyager mission is how it continues to send data from such a great distance. The spacecraft's ability to communicate with Earth is a testament to the advanced technology and engineering behind its design. The Deep Space Network, DSN, with its antenna complexes in California, Spain, and Australia, plays a crucial role in maintaining contact with Voyager 1. These antennas can pick up extremely weak signals, allowing us to receive data from billions of kilometers away. Despite technological advancements, challenges remain in communicating with Voyager 1. As the spacecraft travels further, signal travel time increases, signal strength weakens, and data rates slow down, complicating communication. However, the sensitive receivers of the DSN ensure even the faintest signals are captured, allowing scientists to continue their research. Voyager 1 is powered by a radioisotope thermoelectric generator, RTG, converting heat from plutonium-238 decay into electricity. Over time, the power output of the RTG decreases, limiting the spacecraft's ability to operate its instruments and communicate with Earth. To conserve power, engineers turned off Voyager 1's cameras in 1990. Today, only 4 of the 11 scientific instruments are still active, collecting data on magnetic fields, solar winds, and cosmic rays. In the coming years, Voyager 1 will continue to send valuable data back to Earth until its power supply is depleted. Scientists estimate that in about 8 years, the spacecraft will no longer have enough power to operate its instruments or communicate with Earth. When this happens, Voyager 1 will drift silently through space, a testament to human ingenuity in the spirit of exploration. The Voyager mission has been an incredible journey, providing a wealth of knowledge about our solar system and beyond. The data collected by Voyager 1 has expanded our understanding of the outer planets, their moons, and the interstellar medium. The mission has inspired generations of scientists, engineers, and space enthusiasts, highlighting the importance of exploration and discovery. As we celebrate Voyager 1's achievements, it's important to recognize the dedicated team of engineers and scientists who made this mission possible. Their hard work and ingenuity have ensured the success of the mission, allowing us to explore the farthest reaches of our solar system and beyond. Voyager 1's legacy extends beyond its scientific achievements. The spacecraft carries a golden record, a phonograph record containing sounds and images portraying Earth's diversity of life and culture. The record includes greetings in 55 languages, music from various cultures and eras, and natural sounds like thunder, birdsong, and whale calls. The golden record serves as a message to any extraterrestrial intelligence that might encounter the spacecraft, offering a snapshot of humanity in our planet. As we look to the future, the data and discoveries from Voyager 1 will continue to inform and inspire new missions and explorations. The spacecraft's journey into interstellar space is far from over, and it will continue to send back data until its power supply is exhausted. Even after it falls silent, Voyager 1 will remain a silent ambassador of Earth, traveling through the cosmos for millions of years. In conclusion, Voyager 1's journey is a remarkable story of exploration, discovery, and perseverance. The spacecraft has traveled farther than any other human-made object, sending back invaluable data and inspiring generations. Although the end of the mission is near, the legacy of Voyager 1 will continue to inspire and inform future space exploration efforts. Thank you to the Primal Space patrons who help support and research our videos. If you'd like to contribute, visit patreon.com/primalspace, where we're giving away a Saturn V LEGO set once we reach 50 patrons. Make sure to subscribe and join the discussion as we continue exploring the wonders of space. Thank you for watching, and I'll see you in the next video.